Here we're covering the 2019 Higher paper. This is paper 1 and it's question 14 in that paper. Now this question focuses on logarithms and exponentials, but particularly logarithms themselves. Now before we approach a question like this, we need to remember all the rules associated with logarithms. We need to remember how to use them, how to manipulate them, and what we're looking to do when it comes to solving an equation, for example like here in part B, when it comes to working with logs. So we have to remember, for example, if we've got two logarithms to the same base, log to the base a of x plus log to the base a of y, that can combine and give me log to the base a of x times y. If I have log to the base a of x, take away log to the base a of y, that becomes log to the base a of x over y. If we have log to the base a of x to the power of n, we can bring the power down in front and make that n times log to the base a of x. If we have log to the base a of a itself, that's equal to 1. And if we have log to the base a of 0, we can't do it. That's undefined. Now using these rules, these help us to manipulate some sort of expression or equation which involves logarithms, and they allow us to solve it. So for part A, it's asking us to evaluate this here. Now whenever you see a word like this, evaluate, what that means is get an end value for. So I've got to take this, do something with it, and get an answer and an end value for it such that I can have something written on its own. Now what I'm going to do is I'm going to use these rules of logarithms here in order to do it. Now if you look at this log here, because this is log to the base 10 of 4 and this is 2 log to the base 10 of 5, I can't combine them. It's not like combining x plus 2x. Log to the base 10 of 4 is not the same as log to the base 10 of 5. They're different things. We can't put them together. However, if I get rid of the 2 in front of it and put it here as a power, I've got 2 log to the same bases, so I can then combine them using these two rules here. So I'm going to just take the 2 up to the power, and I'll make it log to the base 10 of 4 plus log to the base 10 of 5 squared, which is going to give me log to the base 10 of 4 plus log to the base 10 of 25. If I then combine them, I'll end up getting log to the base 10 of 4 times 25 of 100. Now looking at that, you might think, hey, I've done it. I've done my job, simplified. However, what we want is just a single numerical answer for this. And that's not just a single numerical answer, it's got a logarithm. This is where we have to start to think. When you've got something like this, look at the number you've got the log of. Say to yourself, can I write that in terms of the base number here? Now 100 I know is 10 squared. So if I write that as log to the base 10 of 10 squared, I can then use this rule again to bring the power down, which I know then is 2 times log to the base 10 of 10. Now 2 times log to the base 10 of 10, well log to the base 10 of 10 follows this rule here, so that's 1, so it's 2 times 1, it's 2. Job done. So that's it now, and I've evaluated it and got a final value for that there. Now the second one is I want to solve this here, so this equation here. Now you'll have two sides to it, and you'll tend to have one side which will have logarithms all to the same base, and you'll have another side which either has logarithms or it will just be a numerical value. What we want to do is get all the logs to the same base on one side, get them combined, and then get rid of that log. It's a similar idea to solving a general equation. We want to get all the x's on one side, all the numbers on the other, and then we can solve it from there. So if I combine these two here, what I'll end up getting is log to the base 2 of 7x minus 2, and it'll be all over 3. Because I'm subtracting, it's going to be a divide. And that equals 5. Now if we think back to another rule that we've got for logarithms, that log to the base a of x equals y, what I can write that as is that x equals a to the power of y. So I can use this rule here, and I can then rewrite that as 7x minus 2 over 3 is equal to 2 to the power of 5. Now I've got an equation just in terms of numbers. I can solve it from there. 2 to the power of 5, well, that's just 32. So I've got 7x minus 2 over 3 equals 32, and then just start to solve it like normal. This here is an S1 skill, solving an equation like this. Multiply both sides by 3. What I'll end up getting is 7x minus 2 is equal to 96. So 7x is equal to 98. So if I divide both sides by 7, I know then that x is equal to 14. So there we go, I've solved the equation for that. Now this type of question here typically is worth 3 marks each. So this first one, you get your marks by starting to manipulate it here, getting them together in one, and then getting a final answer by continuing manipulation. For the second one, what we then get is we get 1 mark for combining it, we get another mark for then getting rid of the logarithm, and a final mark for getting a solution at the end. So 6 marks over 2 parts, all with basic skills and rules of logarithms, something that hopefully we can remember from the course and apply in this sort of question.